Hello guys, welcome to Education India. In this video tutorial, we will be teaching you the concept of mixture and alligations. This is the first part which consists of the basic concepts. In the next part, we will be dealing with some of the advanced topics. So let's get started. Alligation, it enables us to find out the ratio in which two or more ingredients at a given price must be mixed to produce a mixture of a desired price. Now let's consider that we have two groups. The average of the first group is A1 and the number of element in that first group is N1. Similarly, the average price of the second group is A2 and the number of element there is N2. The next term is AW, that's we called weighted average. It is the average of the new group formed. Now we have 5 parameters in our hand. The average of first group A1 having the number of element N1, the average of second group A2 having the number of element N2, and AW with the average of the new group formed. So now there are just two situations. First, in which the ratio N1 and N2 will be given, in which the two ingredients should be mixed to produce a mixture, and we need to calculate the weighted average of that mixture. Second is the case when we will be given with the weighted average AW and we need to calculate at what ratio should the ingredient be mixed to produce that weighted average. So let's derive an equation. How do we calculate weighted average and the ratio? The difference of weighted average to the average of the quantity, let's say B, is A2 minus AW, and similarly the difference of the weighted average with the ingredient having average A1 is AW minus A1. This ratio is in proportion with N1 and N2. What it means basically in mathematical form is this. N1 upon N2 is basically the ratio of the difference of A2 and AW with A1 and AW. Now this formula will be used to find out the ratio in which the ingredient should be mixed to produce the weighted mean average of AW. Now let's focus on this equation. What this equation tells us, this equation will enable us to find out the weighted average AW having A1, A2, N1 and N2 in our hand. Let's go through a basic problem. There are two varieties of rice costing rupees 10 and 12 per kg to be mixed together at a ratio of 1:2. We need to calculate the average price of the resultant mixture. Now first of all, we should note down the parameters given to us. A1 is the average price of the first group, that's 10. A2 is the average price of the second group element, that's rupees 12 per kg. N1 is to N2 is 1:2. It's the ratio of the quantity being mixed. So the pictorial representation of the given question is this, and the corresponding data has been fed here. Now first of all, the ratio N1 and N2 has been given as 1:2. We can assume N1 to be K and N2 to be 2K. Now we have N1, N2, A1, A2 in our hand. We know the formula, we will be putting it in the previous formula. Now as we have N1 and N2 along with A1 and A2 and putting the values in the formula that we know to calculate the weighted average of the mixture formed, we will be putting N1 as K, A1 as 10, N2 as 2K and A2 as 12. So solving this formula for AW, we will be having the values of AW as 11.33. The average price of the resultant mixture is Rs 11.33 per kg. Whatever be the ratio of the quantity being mixed, the average price should always lie in between 10 and 12. Now let's say we have mixed 1% of rice of costing rupees 10 per kg and 99% of rice costing rupees 12 per kg. Still the resultant mixture won't be rupees 12 per kg. It will be somewhat less than rupees 12 per kg. Similarly for the reverse case also, 99% of rupees 10 per kg, 1% of rupees 12 per kg. Still we will be having somewhat rupees close to rupees 10 per kg. Now let's go through the problem number 2. On mixing two classes of students having average marks 25 and 40 respectively, the overall average marks obtained is 30. We need to calculate the ratio in which the classes were mixed and the number of students in the first class if the second class has 40 students. Firstly, we will be drawing the pictorial representation of the data. As given in the question, we have A1 as 25, A2 as 40, and the weighted average of the class as 30. Using the equation number 2, that's N1 upon N2 equals the difference of AW and A2 with A1 and AW. So that's AW minus A1 is 5, A2 minus AW is 10. So A2 minus AW has been put as 10, corresponding for AW minus A1, that's 5. So the ratio in which the classes were mixed turns out to be 2:1. So the number of students with the average of 25 was double that of the number of students with the average of 40. Now for the part B, we need to calculate the number of students in the first class if the second class is 40 students. It's very simple. According to this equation, we have N1 equals 2 times N2. So N1 equals 2 times 40, that's N1 should be 80. So the number of students in the first class should be 80. Now I will tell you how to distinguish between N1, N2, A1 and A2 in the upcoming slides. Students, they generally face difficulty in differentiating A1, A2 with N1 and N2. I will be clearing this doubt in the upcoming slides. Before that, we will be analyzing some more problems. Pure milk costs Rs 36 per liter. A milkman adds water to 25 liters of the pure milk and sells the mixture at Rs 30 per liter. We need to calculate how many liters of water does he add. So it's very simple. Given in the question is A1, that's Rs 36, A2, that's Rs 0, because we are considering the cost of water as 0 here, and the resultant mixture price comes out to be 30. So N1 upon N2 is AW minus A1 upon A2 minus AW, that's 5:1. So that means what? For every 5 liter of milk, he adds 1 liter of water. So the milkman adds water to 25 liter of pure milk. So by unitary method, we can derive for every 25 liter of milk, he should add 5 liter of water.